This video is designed to serve two purposes. The first purpose is to show you an example data analysis assignment to hopefully clear up some of the questions that people are having about what types of files to submit and what they should include. The second component of this video is to try to explain all the steps I took from the raw data to the final data analysis report. Usually you only get to see the final report in a data analysis, so I'm hopeful that by illustrating all the steps I took in between, it will be useful for people to understand how a data analysis actually gets performed. So you can start by opening this prompt file within the example project folder, and you can see that it describes the problem that I was answering when I was performing this data analysis. Your prompt for this class will include both the description of the scientific problem like this, as well as specific instructions about the assignment. Here, the goal was to download the data on the last 7 weeks worth of earthquakes from the USGS site and perform an analysis relating earthquake magnitude to earthquake depth, and then to ask what can we infer about the relationship between those two quantities, potentially accounting for other variables. If you go into the assignment folder, you'll see that there's a couple of different files, and these are the files that I would have submitted for the data analysis itself. First, if you go to the example analysis PDF, you'll see this is actually the write-up of the data analysis that I performed. It includes all the components, including an introduction, methods, results, and conclusion section, and a list of references both for the scientific background that I've described as well as for the statistical methods that I've used. At the end of this file, there's actually a list of references that refer to all the references that I included in the text. So this example analysis is written out in the style of an essay that describes the story of the problem, just as we discussed in the Organizing a Data Analysis lecture in week 2. The other components that you'd submit are the figure file. So this is actually the final figure that you'll be including in your analysis. Everyone is required to submit one figure for this for each data analysis, although figures can have multiple panels. I wouldn't suggest more than about 4 panels for your figure, as any more will start to be confusing and hard to understand. You can also submit a figure caption for your figure. The figure caption should describe the figure and all of the results that are presented in that figure in plain language so that people can understand what the figure means. Finally, the last component of the assignment is either a .rmd or .r file. So the RMD file is an R Markdown file, and the .r file is an R script. The RMD or .r file should reproduce all of the numbers that appear in your example analysis. So in this case, this example has earthquakefinal.rmd. This is an RMD file which can be run with knitr, and it will execute all of the R code that I have here and will reproduce every number that appears in the final analysis. I've also annotated this with where these numbers appear in the actual data analysis write-up. So here it's the methods and data collection section, here it's the results paragraph 1, and so forth. This will make it easier for other people to evaluate the reproducibility of your analysis. To get the full reproducibility points for this class, you will need to use R for your analysis. And the reason why is because other people will need to evaluate your code, and we need some level of uniformity so that people can execute other people's code. So the first line, or one of the early lines of your analysis, should be loading in a .rda file, which will be the data file for the class. I'll also provide the data in CSV format, but I suggest for reproducibility that you actually load the data in the .rda format because it's the most cross-platform compatible and will lead to fewer bugs when other people try to execute your code. So that's a little bit about the actual assignment itself. Now I'm going to go through the rest of these files to show you how this analysis was performed. So I'm going to start off by going into this code folder. So I have 2 components of the code here. I have final code and raw code. So I'm going to start with raw code, and again I have a R Markdown file that reproduces all of the analyses. So you can open up the raw earthquake Markdown file, and you can actually see all of the R code for all of the analyses I performed when I was first just exploring this data set. You'll see that many of these analyses that I performed didn't actually appear in the final analysis or the final R script that I would have turned in. If you open the HTML file, you can actually see the compiled version of this code. So the compiled version of the code in an R Markdown file has all of the R commands that are executed, all of the text descriptions that I had for all of the analyses that I did, and then all of the output from the R code itself, including things like figures. So you can take a look at this and see all of the analyses I performed when I first downloaded the dataset. This is comprehensive. I didn't leave anything out from the raw analysis that I performed. So once you've looked at the raw code, you can go to the final code. This is the same RMD file that I would have submitted, and it appears exactly like this in the assignments folder. Again, you can look at the RMD file itself, or you can open up the HTML file. The HTML file is the part of the file that has been compiled, and so you can actually see, again, all of the output of the code, and you can see annotated, results paragraph 1. This is the plot that I looked at to be able to describe the patterns over time and so forth. So now that I've looked at the code folder, I have the raw code and the final code. Next, I can go and I can look at the data. So I have a couple of different data files here. I have the earthquakes.csv file. This is the file I originally downloaded from the internet. And quakesraw.rda is the RDA file that was generated that has all of the final data that I used. Next, after the data file, you can look in the figures file. So in the figures file here, I actually only have the final figure that I included in the manuscript. So this is the example of the final figure here in PDF form. You can actually include in your figures file in an actual data analysis the raw figures that you've created when you're doing your raw data analysis. But those, for me, in this particular analysis, actually appear back in the code folder. And the reason why is when you run an R Markdown file, it actually generates the figures and stores them in a folder within the code folder that you created the R Markdown file in. So if we go to raw code, you can actually see that there's a figure file here, and this figure file has actually all of the figures that I created when I was performing my raw data analysis. Okay, so that's within figure, within raw code, within code. So the last component or the last file folder in this example project folder is writing. And so I have some files here. I have in both Microsoft Word and PDF format the example analysis and the figure caption, as well as the prompt document, again, in Microsoft Word format. And so these are just, again, the actual analysis files that I wrote up at the end of the analysis, only including the analyses that I thought were appropriate for the final analysis. So hopefully you were able to take a look at this, and if you have any questions, please feel free to post them to the message board.